You can assign a unit of measure to each of the attributes you create, and this unit of measure is more than just something for looks or just for a string identification. If you actually make an assignment of unit of measure that's meaningful, then that's something that has mathematical implications. So for example, if I go into this level here, the level is a measure of length essentially, and I say that okay, I said that this was feet. I'll go ahead and identify this as feet, and now because this is identified as feet, if I decide that I would like to look at this in different ways, I can simply go here and in most of our Pi clients and choose how we're going to display that unit of measure. And because we know what this unit of measure represents mathematically, when I change this to, let's say, I don't know, we've got some folks coming in who are more used to seeing this in meters. We'll go ahead and switch that to meters. It still has a unit of measure of feet, but we've decided to display it as meters. And we're going to go ahead and treat it mathematically as a unit of measure that has a definite ratio of feet to meters, etc. So as we move this around, as we do calculations based on this, if we decide to change the unit, let's say we're going to go ahead and change this to inches, that's going to show up based on what that calculation or that unit of measure really represents mathematically. Now you'll notice later on when we discuss formulas, this actually has very important ramifications with regard to doing calculations. If you have a data reference that's a calculation, then some of the inputs, odds are some of the inputs are going to have specific units of measure that, that require conversion during the calculation, and that conversion happens automatically. So if you specify the inputs and what unit of measure we're going to use for that input, then that conversion is going to happen without you having to write that into the formula. We will simply look at what you would like to regard that as, is it inches, feet, meters, etc., and then use that in the calculation. So let's take a look at how these unit of measures are actually defined. If you go into the navigation pane down at the bottom here, you'll notice it's not in the library, it's all in its own separate area here. And this is something that spans all of the AF databases. So, if you have more than one AF database, they're all going to share the same unit of measure definitions. Now, unit of measure definitions are all based on certain, I guess we would call them base class definitions that we can then derive other classes of definitions from. And if we look over here, this is a list of the classes, and then the individual unit of measures are over here. So if we go back to our measurement of length, length is one of our base classes. It's one of the fundamentals. And you can see some of the different unit of measures that are based off of that length. Now, in each one of these sets of units of measure, you'll find a specific unit of measure that represents the canonical unit of measure. In other words, the unit of measure that's being used as the benchmark for all the other units. All the other units are essentially derived from that. Let's take a look at how this works in the case of meter. If you look at this meter definition, we look at its properties. This definition is basically a meter without any qualifications. We're defining this as a basic unit that we're calling a meter. We'll take a look at what a kilometer is. We take a look at its properties. This kilometer is based on this canonical unit of measure called meter, and then we use a reference unit of measure in this calculation. So the reference we're using here is meter. We're saying simply a kilometer is 1,000 of these reference unit of measures. So a kilometer ends up being 1,000 meters. So as you can see, the definition of meter, it requires no definition. It's the canonical unit. Now you can actually see that if you look at the definition of length. I'll go ahead and go over here and right-click on properties here. As you can see, length is defined as a meter. That's our basic unit of measure. Let me show you another example. If we take a look at foot, that unit of measure, look at how that is defined in relation to the meter and in relation to this reference unit. Now in this case, the reference unit we're using is inch. It's based off of this base class called meter, and what we're saying is that this thing that we're calling a foot is equal to 12 of these things we call inches. Well, so to define that in relation to meter, let's go to the definition of inch. We look at an inch, and an inch is defined back to that base class called meter. It is defined as, what is that, 254 10,000ths of 1 meter. So that, we take that as the definition of inch with regard to meters. We define feet with regard to inches. And if you didn't guess the big finish to this yet, the big finish is if you have a need for a specific unit of measure that's not here, well, you can define that yourself. So let's just say, for example, let's go back to our elements here. Let's say we're looking at level. We just saw how level could be in either inches or feet or meters. I can choose to show this just about as anything I'd like to show it as. It's all essentially going to be variations of that canonical unit, the meter. So this is 27 meters, and then any variation from that is going to be based on the calculations that you saw defined. But there may be some things here that are missing. You may be interested in a different a different unit of measure. So what do you do if that unit of measure is not here? Well, I'll give you an example. There's actually some folks that may be in your legal department who have a need for documenting their properties based on rods. Believe it or not, in some jurisdictions in the United States, you go into the legal definition of property rights and you'll find things measured in the Old English rod. Now, I know for a fact that a rod is equal to a little bit more than 5 meters, but I don't see this option called rod here. And we did create a bunch of default units of measure. These default units of measures are all coming from the International System of Units. So we did our homework here, but one of the things we didn't add is this thing called rod. So if I don't have rod and I need rod, I'll just go in here. I'll choose a new unit of measure. I'll call this a rod. We'll just abbreviate it rod. Now this is going to be based off of that canonical unit called meter, because it's in that base class. And in this case, the reference unit of measure is going to be meter because I know what that multiplier is. That's 5.0292. That's the number of meters in a rod. And once I've done that, now, for the sake of those folks that are documenting property rights or where a boundary begins and ends, now I can start expressing things in terms of rod. It actually shows up over here. That's one of the options I have now, is to display this as a rod. We can see that's actually 5 rods. Actually, that would probably be something I'd want to change. Instead of an int, make that a real. Anyway. So that's an example of how you can extend this set of units of measures. We can extend that as we need to. Now, it's going to be the exception to the rule that you really need to extend that. But not only can you extend the units of measures themselves, you can actually create your own base classes of unit of measure. I mean, if there's something that we forgot, or if you're in an industry that has got some really obscure units that we've never heard of it's not represented in the International System of Units, you can define a brand new base class. Now let's take a look at how base class works real quick. Let's take a look at length again. Length, if we look at it, is defined as a meter. I mean, that's basically the base class. Take a look at this derived class here. There are certain base classes, and you'll find those listed in your class workbook. There's certain base classes, but then there's certain derived classes. And area is one of those derived classes. So what is area? Well, if you remember, area is simply length squared. So that's how we're representing area in this derived class. And as you can see, the canonical unit that we're using here is the square meter. That's the base unit for measuring area. And if we take a look at all the things based on area, they're all using that. Here's the default class, that base or canonical unit here with the check mark. Everything's based off a square meter. Well, we can go one dimension further now. That's length is one dimension, area is 2 dimension. Volume, would be something we would measure in 3 dimensions. And no surprise here, if we take a look at the definition of volume, it again goes back to that base class called length. It's length cubed. So you know, length times width times height, that's going to be the volume. And take a look at all of the units based on volume. So the cubic meter is where we start, but we can, you know, we can do barrels, cubic feet, etc. All of those derived from that simple cubic meter. So all of these things are extensible. It's going to be rare when you actually do need to extend these, but it's good to know that these things are available. And just parenthetically, I should add, I think one of the big surprises in the rollout of AF is how much the end users actually think this is about the best feature of AF. Tremendous acceptance among folks using this day in and day out to be able to go into ProcessBook or any of the clients and immediately change unit of measure and see the unit of measure they want to see without having to fool around with calculations. So the unit of measure ends up being a real powerful, powerful incentive for folks to switch over to a visualization that is AF based, because all the units that you might want to display, all the different things that how you may want to display this are available for you with very simple user interface to do that.